Hello, folks. It's projectile time once again. I'm checking in to see how you're doing and give you a little bit of support. As you've been thinking about projectile problems the last day or two, we've developed some tools, and I just want to remind you what those look like. I've written the tools with you this way. We said dx, distance horizontal, is vx times t. That is how fast it's going times the time is how far it's going to go. That's one of them. Secondly, we agreed simply that the velocity x at the end is going to be the same as the velocity x at the beginning. That really doesn't deserve writing an equation, but it's an idea we worked with. Thirdly, we talked about velocity vertical y, so vy final, as vy initial, the speed y at the beginning, plus at, and of course a is really gravitation there. And finally, I showed you, didn't really help you see where it came from, but a tool for vertical distance that works great as long as we start from rest. And again, that one is 1/2 at squared. Now, I take the time to show you those one more time because I want you to notice how they look just slightly different than what shows up on this piece of paper. This first one looks just the same. dx vxt matches right up. You see vertical velocity is gt, and we have over here velocity y final at. Well, at and gt are the same thing if the acceleration is gravitation, because you know this number is gravitation. I added an initial term v1 or v initial in there. If you have one, great. If it happens to be 0, well, fine. Then these two are the same. And again, you look at the third equation that says dy is 4.9 t squared. That's exactly the same thing we're doing over here. Again, as long as it starts from rest. Of course, notice that 1/2 of g, that is 1/2 of 9.8, is 4.9. So just to clarify, those are really the same tools that we looked at yesterday. Here's the concept. I want you to try out these problems. In each problem, you want to ask yourself, what information do I have? What information do I am looking for? And what tools tie those together? So I'd like to look at the first one with you for just a minute. I might also encourage a picture. Pictures are super handy when you're dealing with problems like that. I've got a cat jumping from one roof to another. It's 5 meters away. So here's one roof. 5 meters away, there's another roof, and it's 3 meters lower. So something like that. So we know the distance horizontally in here is 5 meters. And we know vertically that there's a 3 meter drop. So the idea on these problems, let's figure out what is it we know. So we know the information we just talked about. We're looking for horizontal speed. So let's give that a physics name. The thing we're looking for, horizontal speed, that's velocity in the x direction. Now we have a tool that helps us with that. Let's see what we can do in order to make it to the other. So we know that vx times t equals dx. That's the tool we have that involves horizontal velocity. Now the good news is we know the horizontal distance is 3 meters. We don't know what vx is. I stink, we don't know what the time is. So now we're stuck. But what I recommend you do is when you're stuck is then we go over here and flip. This happened to be the horizontal part of the problem we were working on. Now I want you to look at the vertical part of the problem. And you notice we know in 3 meters something falls. Well, that 3 meters is a distance vertical. And if it becomes distance vertical, again, we talked about starting from rest. This tool we need is 1/2 at squared. In this case, boy, that's useful because we know this is 3 meters. And we know 1/2 is just a number. We know a is 9.8 meters per second squared. And the t suddenly becomes something we can solve for. So here's a tool that we can use to find the time. And you'll notice once you know that time, once we have a value, then all we're going to do is stick it over here back where we got stuck in the first place. And then you can figure out that initial speed. So again, strategy on the problems, use those tools, flip back and forth between horizontal and vertical. With a picture, it's helpful to keep track of which is which. Once you get started, I think you'll discover switching back and forth when you get stuck is really a useful tool. So again, we've got some projectile problems to try. Please reach out for some help. I'll be around during office hours 9 to 10:30, and let's see if we can help you make some sense out of those. Thanks. I have also left a set of videos from the physics course at the U of M. I would strongly encourage you to watch them. One, they're really cool, and two, they do a great job of tying together some of these ideas that'll help you with the problems. So do check those out today if you get a chance. They're pretty neat. Thanks. Have a great day.